Orienteering is the process of using a topographic map and compass to find controlled points and eventually end up at a specific location. We will be modifying the orienteering process due to not having a large enough scale. The first thing you need to know are the important parts of your compass. This arrow here is your sight line. The inner red arrow that moves is your magnetic needle. This other red arrow is your orienting arrow, and this twisty thing is your azimuth ring. Now, you need to find the bearing between your 2 points. Our first point will be here at the high school. Our second point will be this small hill right here. Using your ruler, draw a straight line between your 2 points. After you draw the line between your 2 points, twist your azimuth ring to align the orienting arrow with your sight line. Then place the middle of the compass over your first point and align the sides of your compass with the straight lines on the side of your map. Then find where your line that you drew intersects the azimuth ring. It intersects at 36 degrees, so we know that our second point is 36 degrees northeast of our first point. Our next step is to find the distance between the 2 points. To do this, we need to convert the inches on the map, or centimeters on the map, to using the scale to how many feet they are in real life. Starting, we will measure the amount of centimeters between each point. This is about 5.3 centimeters. At the bottom of the map is a scale. Using the scale, measure 5.3 centimeters. That's approximately right here. So we can see that it's over 4,000 feet. And using this amount right here, we can see that it's about 200 feet extra. So it's approximately 4,200 feet between our 2 points.
Bring location and adjust for declination. Declination is the number of degrees difference between true north and magnetic north. Subtract your declination number from the number of degrees you found on your map between your 2 points. This is called adjusting for declination. Declination is 21 degrees, and we found the degrees between our 2 points on our map to be 36. So you'd subtract 21 from 36 to get 15. Compass is adjusted for declination. Line up your magnetic needle with the orienting arrow. Look in the direction of your sight line and pick a point on the horizon that looks like the general point that you're trying to find on your map.
Because our second point is a small hill, we presume that this small bump is our point B. Before you start this orienteering process, it's recommended to measure how many of your paces you can do in 100 feet. For me, I walk approximately 35 of these paces in 100 feet. From there, you take the amount of feet between your point A and point B and divide it by 100. Then multiply that number by the amount of paces it takes you to walk 100 feet. For me, point A to point B is 4,200 feet. So divide that by 100 to get 42, and then multiply that by 35, the amount of paces it takes me to walk 100 feet. That leaves us with approximately 1,470 paces from point A to point B. So to that little hill over there, it's 1,470 paces, which is why we are not going to walk to point B in this video.
In a normal orienteering course, you would follow the sight line on your compass to guide you in the direction of the point on the horizon that you found earlier, all along counting the amount of paces it takes you.
Once you arrive at point B, or for us, our little hill, you would repeat this whole process it took you to find point B to find point C. And then you would take that whole process and find point D, and then E, and then F until you arrive at the finish line. Now, using this lovely obstacle course, we will show you a shortened version of what it would be like on an orienteering course, without a map, just using degrees and feet.
These are our orienteering instructions.
This is our starting point, the concrete bench closest to the flagpole. That doesn't have a flag on it. We're at our starting point, we need to adjust for declination. Our first degrees is 340, so 340 minus 21 is 319. Now that our azimuth ring is lined up to 319, we need to align the magnetic needle with the orienting arrow, and then follow the sight line and pick a point that we will walk towards. Probably that black car right there. So we did the math to find how many paces it would take going in that direction to get to our point. So it's 10.5 paces because you divide 30 feet by 100 and then times it by 35 because I have 35 paces and 100 feet. So now we are going to walk towards our destination. 10.5 paces. Our starting point, and after 10.5 paces, this is our ending point. Now that we're at our second point, we need to find our third point, which is 80 degrees adjusted for declination, so minus 21, which would be 59. Then, since it's only 100 feet, and we know that 35 of my paces is 100 feet, then we know that you walk in that direction 35 paces. The last point was over there, and we walked all the way over to here. There was our starting point right over there. But we are at our point. We can find our next point, which is 310 degrees minus 21, so that would be 289. Once you set your compass to 289, you align your magnetic needle once again with the orienting arrow and follow the sight line. So our point is probably, we are going to walk towards that light post. Right there. And we are going to walk 21 paces because 0.6 times 35 is 21. So our destination, our final destination is this lamppost. Now, you have to do a good job of explaining where you end up. So take a look around and use permanent points to explain our final destination.
For example, we are at the southernmost light post in the northern parking lot of the high school, directly north of the flagpole.
There's the flagpole.
Normal orienteering course, you would be timed. But since we were trying to demonstrate to you guys, we didn't time this. So we came in dead last to our many, many competitors on this lovely Saturday crowded morning in school. In summary, we showed you how to convert distance to feet, how to find a bearing on a map, how to adjust for declination, how to follow the sight line to find a point on the horizon and the general direction of the point on the map that you were trying to find, how to use paces to measure distance, and how to do a mini orienteering course. Orienteering would use all of these skills combined to keep you from getting lost.
Ideally.
We hope you learned a lot from this video. Good luck and have fun orienteering.
And don't get lost in the parking lot because there is literally no one here to save you.